Okay, I just want to tack this on to the beginning of the next thing. This is still the old style array list. I asked myself the question, how would it know how to print to print it to add it to a list box? Well, it can do it. It can. There's a toString for every object. That's sort of the default. And if you don't specify a new one when you design a new class, which I didn't for the die, right? Then what it will do by default, and I'll show it to you, is this. It'll tell you the namespace and the type, the name of the class. That's how it toStrings. So it would not actually crash adding all these things to the list box. What would crash though, is still a problem, is if you try to do something like this. Right? It still doesn't know how to roll a bare bones generic object. There is no roll method for an object. That's only for dice. So you still have to downcast for things like that. Usually here's how you know you're going to have trouble. You're not likely to have much trouble until you hit the dot after something. And then that's determined, what's after that dot is determined by the specific data type it is. And in this case, I'm trying to treat a generic object as if it were a die. And sometimes it is, and sometimes it's not. When it's 23 and L1Z1X, it's not a die, so it won't have a roll method. So there's no way the computer can predict what an object's going to be unless you what's called look up downcast. It's a pretty good graphic novel that just came out recently that I got, but it's also the term you use in coding for taking something that is a specific type and making sure that it matches the data type that it is by adding it to assigning it to a variable of the appropriate type. So item is just an object, but when item does happen to also be a die, you want to cast it to a die variable so you can use it as a die. So that's just a note on the last thing. That took 2 minutes. That's enough. I'm going to go, we're going to talk about generics now. I'll spend a few seconds on this too, and then I'll be done. You can override the toString method of any object. So this is what we're doing in our dice class, public class die, the rolling and everything. And I made it to where when you do the toString method, it says, I'm a die, plural dice. You could do other things too, like maybe roll a die, get the roll and say what the roll is or something like that. But here's how it behaves when you run it in this particular. It's still kind of boring actually, but you can make this even more flexible where, like, again, you could roll the die and store that and then print the number here instead or whatever. So that's enough about that. And now we'll talk about generics. So I might be doing a couple pauses here and there, but we have started the new thing. So what I did is I removed the reference to just system.collections and added generic to it. So now it doesn't know, because I don't have just collections here in the using the namespace stuff for that. So it doesn't know what an array list is anymore. So now we're going to move on to using typed collections. So I'm going to pause you here and we'll start doing that. So here is our example. What we have to do again is change this to generic, and that gives us access to these things. So I have this thing called a list now. Notice the angle brackets and the data type. This data type should specify the type of objects I want to store on this list. So I'm only going to store integers, and it will check at compile time whether or not the thing that I'm adding is an integer. If it's not an integer, it just won't allow it. It will probably, not even at compile time, it'll check it IntelliSense time probably. Let's see. I haven't tried it yet. Check. So here's what it's telling me. It's like, hey, you've declared a list of integers, but this is a string. What are you trying to do? So don't do that. That's what it's trying to tell. So IntelliSense tells you not to do that. Let's run it to show how this works. This is actually already running. Sorry. Let me start it. So do demo, and this is what we do. We add first 23, then we add 12, then we add num, we add num, which is 12. Then we add 3 divided by 2, which is 1, right? Because there are there was one entire 2 and a 3. Oh. then we add the sum of the list. So here's the thing about these lists. Still running. So one of the biggest things I do. You can do some debugging while something's running. That's why it allows you to type, but we're not trying to do that. So, list dot. So this generic list of integers. Here's things you can do. All kinds of stuff. I'm not going to go over all this, but this is the benefit of collections. You've got these pre-baked data structures that behave in a specified way that you can learn the API of and just use to do really neat stuff. So I guess if the things that you're adding to your list are numeric, you can sum them up. So I added the sum of itself up to that point to itself. So if you look, 23 and 12 is what? I suck at this. 10 would be 33 and 2 is 35 and 1 is 36. So there you go. So 36, at the point when I was about to add this to the list, I summed up what I had already, which came out to 36. Then I added 36. If I just repeat this line, you know, it will just keep going, right? So as an example here. So you can also remove things from the list. Let's see, how you remove it though is kind of weird. I think it's the item would be by the value. So let's run this again and see what we get. So it removes the 12. So you get an idea of how this works. Notice that this is much simpler now. I iterate over the for each item I add to the list box. So it's just the for each is over the list collection, which is itself an object. All right, I think that's a simple example that should make sense for you guys who are experienced and saying, why is he doing the for each? Because he could just do the data source. So I wanted to show you that. I try not to think about you guys most of the time because this class is not for you. If you already know stuff, there's pedagogical reasons why I do the for each, but because this opens up a whole other can of worms. But I'm going to go ahead and show it. If you do lst dot, this is for the list box, right? Dot data source. You can set that equal to the list, and then you don't need the for each loop. It's just saying, hey, I've got this thing that's a list. I'm going to make that what needs to be in the list box, and it's a lot more succinct. But I don't want you guys to do this. That's for the benefit of all the smart Alex. Nobody's been a smart Alex to me but there's always one hiding somewhere in every class. So that's for you. Control K, Control U. There you go. This is the way you should work with these things now. Just know how the for each works. Remember from the loops before, with arrays you can use it for arrays, but it makes even more sense here with this collection because it has its own internal order. It's the order you add things in, and then it'll iterate over them. That's enough for lists, and that's not that much time. I'm doing it again. I'll stop. But we'll go over stacks and sorted lists as well, but they're very similar. You just use these angle brackets. Before we do though, let's do this. I just want to show you. You can use this for any type. So this is actually not over yet, but I won't have to do this for the rest of them. This example where I show you can store anything, right? Notice the constructor. It's still a constructor, so it has to have the parentheses here. But you do specify, and I think actually you can take some shortcuts here. You can do this. I think you can infer the type of things but I always just put it because I can't remember whether it's required or not, and it doesn't hurt anything. So, but this other list now, another list, you can only add strings to. Dot add. There you go. It's not even my favorite. I like the arborec. New list of strings. Why does it give me? Oh, another. Sorry, I missed. I meant to type another list, but I didn't. Anyway, there you go. So, it would work the same way. I guess I should show it actually. So for each item in another, there's only one right now, but that doesn't hurt anything. I need to make this appear over here. There you go. So you see how that works. One other thing to show, because this is kind of a mind bender, but these are all simple value types, but what about a die? Can you do that? Oh, perfect. We have more than one die maybe, so now we have dice. I love it. So the whole point of this, why it's called generics, is that you, deep down in the code in the library, the algorithm has been established for how to do anything that's a list, and then the code's been made so flexible that you can make a list of any data type, and you only have to create the code. In other words, you don't have to create lists that work for integers and then create another structure of that's a list that works for strings, and another structure that's a list that works for dice. Really deep down at the bottom, there's a list of objects, but then there's been code added to check what data type you're adding to the list when you specify. So you only have, it's more complex than just a regular list of objects, but it's still just one definition. And because if you have a list of anything, you interact with it in the same way. It provides the same interface, right? The same algorithms. You add things, you remove things. I guess if you can sum them up, you sum them. I don't know how you would sum dice here without getting tricky. We can see what happens when in doubt. Check it out. I just made that up. That's stupid. So I'm going to add a new die. Actually, here's what I'm going to do. There is no list, of course, but I'm going to do that. I don't think I can refactor rename here, but dice. These are all dice, so this has to be all dice. This is going to be painful to watch, but we don't need this many, so I'll just do this many right here. So here we go. Now we can add a bunch of dice to this list, and so what would it mean to add them to the list box? Well, that depends. We could just do this just to test out how this works. So we'd say for each var item in dice, item dot roll. Now you see what the benefit, it's the benefit to you as a programmer in syntax, because you have specified that this list is a list of dice. Therefore, you can infer the type. When I say, and it's a good practice to just put var here so you don't have to think about it, but you could, you could also do this for each die item in dice. This is a list of dice, so you can do this because it knows that each item is a die. It's not just a generic object, it's a die. And that means when you say item.roll, this will be a die that rolls. It understands how to do that because it's not, again, it's not a thing that's been stripped of its die-ness. It is a die, so it can roll it. It knows that it has that method. And of course, it rolls it. We don't see anything because we didn't add each roll to the list box. So let's do that. We'll just lst output dot items dot add each die that we roll. I'll keep this at 15 minutes. That'll be good. So this is the last little example. But I do want you to compare this to what we did before. All right, different types of dice rolling different values. You can see the 6 sometimes appears on the last one, but it'll never appear in the first 2. So yeah, compare this syntax to the generic. I call it generic, but to me it's generic. But to the old-fashioned array list, and see how the syntax is somewhat different. It's a little cleaner here, right? You don't have to worry about the downcasting and all that. But the drawback might be if you did want to have a mixed bag of different types that you're on your list, then you can't really do it here because you specify at the time you create the list what you're putting on the list. Most of the time, in my opinion, And there could be, you know, room for opinion here. This is more useful than being able to mix a bunch of different objects together. You're asking for a disaster there most of the time. But, you know, there might be certain situations, certain jobs where you have to be able to do that. But I can't think of them right now, but there might be. But this is usually a lot cleaner, because usually when you have a collection of things, they're all the same type. So you might as well. And again, the benefit is that you can make a list of anything. So that's there for you to use. All right, that's enough for lists. And I clicked stop too soon. That's enough for lists. In the next video, we'll talk about the next couple of examples of syntax. Those should be short, and then we'll be done.